Here I go online and once I go online I have to set this, as well as I go to this, and now I have to simulate it offline. So when I'm simulating to yet another video, and still we are going to be discussing about automation. In this video we are going to be talking about like sequencing, timing. This is what I'm trying to show you. Like I have this system here which is just flickering, and then I want to increase the time like of delay, and if I'm going to increase the time, I think now you can see the frequency of flickering is a little bit, sustainable, and then I can increase a little bit more. So we can wait a little bit more. So this is the project I would want to initiate you guys to see if you can fulfill. And then I can again go back by sensing something. So you see I have again back reduced the time of flickering. So the on and off time I again reduce it. So I can increase it more again. So this is the project we are going to do. This is a project we are going to do. We are going to program everything over here in the PLC, and then I initiate you through the whole process of how I have to choose the timers, how I have to choose the data registers, how I have to select the inputs and then the outputs. So without wasting much of your time, let me run you through inside here. I run you through. So whenever I'm to start to program, I always enter inside here. This is the environment where I program from. We go to the comment list. The comment list, you may use it or you may not use it. So the reason as why we use it is like I don't want to keep naming my inputs and my outputs with the x0, x1, x2, x3. It's something when I'm debugging or when I'm trying to look through my code, I may not understand what is x1, x2, but when I come here I get to see x0, I name it as start, and then x1 I name it as increase, then x2 I name it as stop, then x3 I name it as decrease. So any programmer who will come will just be understanding my program quickly. And then I go to my start, to my outputs. I have my lamp 1 and my lamp 2, but they are connected to outputs 3 and 4. This is because of the configuration of my PLC. And then I go to my timers. I have used one timer. Then this one is not used because you can see there is no asterisk sign. And then I go to the data registers. I've used two data registers. One is storing my total time, and one is storing my on time. So back to the program itself. So this is how I initiate the program. I just start the program by storing the total time, that is the on and off. That means this total time is going to be like, if it is like 10 seconds, I want to have 10 seconds, I want to have 5 seconds on and 5 seconds off. So this I start by this is an internal memory that gives me a high signal. When I just initiate, it enables a high positive signal. So, and then here is when I'm initiating the system, where I have my start switch and I have my stop switch, and then I have to energize my internal memory M01. So when this M01 is on, I divide. This is a division function. So this division function is going to divide whatever I have stored in the total time by 2. So if you can see I stored 50 and then I'm dividing it by 2. So that means in register D1 I'm going to be having 25. So when I go further ahead, this one, remember I'm using a maintained switch. So if this is closed, this will keep energized, and this is energized. So when this is energized, it is going to be starting the timer. And when my timer is on, this is timer 0. When it is on, it will be on till D0 time. That means it is going to be running up to 50. Yeah, now still my condition is still on. I have now relation. This is a rational way like of comparing this and this. So what is it comparing? It is comparing D1, data in register D1. But remember, D1 we saw the data we got after the division sign, so it is going to be 25. So we get 25 here and we are comparing it with what is in the timer. So when the timer reaches at 25, it is going to give a high signal over here, but it is greater or equal to. So whenever this is greater or equal to, we shall be getting the output. So that means when the timer is the timer is from 0 up to 25, we shall be having no output, and once it goes beyond, we shall be having an output here. Our output will be energized. Then this is where the whole system comes in, because we want to control it. So we are going to go to our increase. So if you want to increase, we have we are using here what we call a falling signal, falling edge trigger. So if you want to increase the rate at which if you want to reduce the rate at which the flickering is going, we are going to add the time. So we're going to be using the add function. So how we use this add function? We add whatever we stored in total time, that is in D0. For this case, it is 50. We add a particular parameter. We are going to be adding 20, and then we store it again in D0. So that means in D0, if there was 50, now it is going to be 70. Now when it is 70, you divide it by 2, and then here you'll be having 35. So now the timer is going to be counting up to 35 to get an output here. So that's how excuse me, that's how we are going to be working. That's how the scenario is. The same for decrease. It's the same, just what's changing is the function that we are using. And now after this, we are going to be having whenever, because if you do it up to this way without doing this step, this is to restart your timer, because whenever you finish, you have to restart the timer, and now the cycle repeats itself. So whenever T0 is showing high, it will restart the timer, so it will continuously now keep in the loop. So apparently I have already shown you how physically it is working, but still I can show you how it can be simulated. So right now I have to just go and compile this program. Over here I go online and once I go online, I have to set this, as well as I go to this, and now I have to simulate it offline. So when I'm simulating it offline, this is what I mean. You can see my lamps are flickering, and they are flickering at a particular rate because my system, is already started, and you can see this is a maintained start. Over here I go online and once I go online, I have to set this, as well as I go to this, and now I have to simulate it offline. So when I'm simulating it offline, this is what I mean. You can see my lamps are flickering, and they are flickering at a particular rate because my system, is already started, and you can see this is a maintained and you have realized this is how you can achieve this kind of a setup using a PLC. So we shall be having a little bit more of the discussions in this formal manner. You can have the simulations online. We can as well as have the practical. So for the practical, I have to just press the start, and then you can see the rate at which it is flickering. But now we can increase, we can reduce it a little bit more, or we can reduce. You see, it is flickering. So this is what we can achieve. So I can press the stop button to stop it, and the whole program is working perfectly, both offline and both online. So thank you. We shall meet in the next videos.